Now available, let's spotlight the 2023.2 Apps and Toolkits release highlights, including new capabilities and enhancements. With lots to talk about in Omega, let's kick things off with the incorporation of the SAGE force field. SAGE 2.1.0 is now available as a complement to mmFF 94. The much more extensively parameterized SAGE provides overall equivalent performance to mmFF 94, with improved handling of certain functional groups. Next up in Omega, we've replaced the built-in fragment library in both the Omega toolkit and application. Expanding on the 80,000 fragments of the previous library, the new fragment library contains approximately 540,000 fragments. The upgraded library reduces runtime on both GPU and non-GPU enabled machines without sacrificing accuracy. In other Omega news, we've created new capabilities in Flipper for the enumeration of stereochemistry at atoms and bonds. Flipper is a utility program within Omega that ensures that all molecules input to Omega have all their stereochemistry defined. Previously, Flipper performed enumeration on atom or bond stereo in a coupled fashion. The new capabilities offer the user fine-grained control over enumerating different types of atom and bond stereo centers in an uncoupled manner. Notably, SAGE continues to improve in both its geometric and energetic accuracy, which is available in the OEFF toolkit. On to support updates. Python toolkits now use pyproject.toml to declare their metadata and dependencies, and no longer use the deprecated setup.py method. Additionally, support for macOS ARM64 Java is now available. Following the format updates to PDB entries, we've updated the mmCIF parser in OEChem to the latest version for stability and reliability. New to the OEChem toolkit in this release, we've added a preliminary API that enhances our OEChem reaction support by implementing a reaction auto-mapping facility based on the maximum common substructure matching engine in the OEChem toolkit. You can visualize auto-mapping results in PICTO through a newly added chemistry menu. You can use the resulting mapping correspondence to guide the manual creation of reaction smirks or to provide display or feedback to chemists about a reaction change. Or, your results can subsequently be used to precede the reacting center atoms and bonds for a given reaction transformation. Next, we've made improvements to the robustness of our torsion-scanning algorithm by adding the ability to optimize in internal coordinate space as well as in Cartesian space, producing more accurate results. Lastly, we've improved the robustness of protein ligand optimization with FF14SB OpenFF in SZYBKI with updates to the parameter assignment algorithm and a new option to apply a long-range cutoff for interatomic interactions. To learn more about the 2023.2 Apps and Toolkits release, visit docs.isopen.com.